Hi guys, for today's lesson we're going to be dealing with using arrays for two-step experiments. So first up, what do I mean by this phrase, a two-step experiment? So it's an experiment which consists of two parts. So e.g. Two coin tosses, like one coin toss and then another one, that's two parts. Or maybe a coin toss and then a dice roll. There's two parts to this experiment as well. So we're dealing with these sorts of experiments, these situations. What we use for these sorts of experiments is an array. So it's a tool used to show the sample space of a two-step experiment. Typically, two-step experiments are a lot harder to kind of work with in terms of probability in your head, so it's really helpful to be able to use an array for these situations. So e.g., let's consider the two-step experiment of a dice being rolled and a coin being flipped. There's our two parts right here. Okay, so the first thing, let's say deal with our dice being rolled. So we have to think to ourselves first, when we're making an array, we're going to draw a vertical line and a horizontal line. And up the top in this section, let's put the outcomes for our first part, a dice being rolled. So from a dice, you can get a 1, 2, 3, 4, 5, or 6. So we put all our outcomes for that up the top. And then for the next part of our experiment, a coin being flipped, you put the different possibilities down the side. So you've always got stuff along the top and down the left-hand side. And so once you've done that, then you want to be making brackets inside your array. So I'm going to make a set of brackets right here with a comma in between, and this bracket is going to line up with the H, so it lines up with the heads, and it lines up with the 1. So I'm literally going to put these two things into this bracket right here. For the next set of brackets, I'm going to put in the H that it lines up with. It lines up with this H, and it lines up with the 2 above it. And I'm going to keep doing this for each set of, for each sort of number. I'm going to get a whole heap of things that are lining up with each number and each, like heads and tails here. So that's going to be a heads and a 4. That's going to be a heads and a 5. You want to try and keep the same sort of order going, so I'm doing my heads first. And then down here, my tails is going to come first, and then 1. You can swap these numbers around if you wish, but you just got to be consistent. And then that's going to be a tails and a 2, so because it lines up with tails and 2, etc. And then you keep going with that. So once you do that correctly and fill in, and you do all the spaces, it's going to look something like this down here. And what you can see is that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different sets of brackets. That means that there's 12 different possibilities for this experiment of flipping a coin and rolling a dice. This outcome here, for example, that represents flipping a heads and rolling a 4. So you can pretty much see that there's 12 different things you can get. So we can use this array to determine the following probabilities. This is all about making probability finding as easy as possible. So what's the probability of getting a heads and a 3? So I can see heads and a 3 right here. That's literally just one different possibility. There's only one heads and a 3. There's no others. So there's only one of those out of a total possible 12 different things. So therefore your denominator is going to be a 12. So your answer is going to be 1/12. Let's try another one. So what's the probability of tails and an odd number? So we need a tails and we need an odd number. So I see that happening here. Tails and 1, tails and 3, tails and 5. So there's only 3 different possibilities out of the 12. So 3 out of 12 simplifies to 1/4 as your final answer. Example 3. I'll just get rid of those up there. The probability of heads or an even number. So we don't need both of these, we just need one or the other. You can have both, but you don't need both. So we need heads or an even number. So all these top ones are heads, there's 6 of them with heads. And we can also have an even number as well. So that's an even number, that's an even number, that's an even number. So I've circled 9 out of the 12 possibilities. So therefore that simplifies to 3/4. So these arrays make these sorts of probability questions very easy to deal with because you just have to look at all the different outcomes. This is like the sample space of our experiment. Okay, so next word I need you guys to understand is the words with replacement and without replacement. What do these mean? So when a two-step experiment consists of the same activity repeated twice, so that might mean, say, flipping a coin twice, the same activity repeated twice. It could be rolling a dice twice, that sort of thing. You are allowed to have the same outcome occur together. So the same outcome, that might be heads and another heads, or a 5 and another 5 on a dice. You're allowed to have the same outcome occur together with replacement. So if you have replacement, it means that the same outcome can happen again. Without replacement, the same outcome or a double cannot occur. So these two things are pretty much opposites of each other. With replacement means that you can get these things happening again, or like a double. And without replacement means that you can't have these doubles. You can't have the same thing occurring again, if that makes sense, in both parts of the experiment. So, e.g., let's consider the experiment of picking 2 letters from the word dog at random. So we're literally just picking a random letter from this, and then we're doing it again. We're picking 2 letters from this word. So with replacement means that you can get doubles. You can pick D and then pick D again. That's allowed. But if you're doing without replacement, that means that if you pick D first, you can't pick it second. So you'll notice this cross here. That means that you can't get D and then D again. That option just does not exist. So instead of putting a bracket here, they put a cross saying that it's not there. So with replacement, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. And with the without replacement option, we've got not one there. 1, 2, 3, 4, 5, 6 outcomes. So this one only has 6 and this one over here has 9. So there's a big difference in the number of outcomes, and that will affect your denominators with your questions. Okay, so let's do some examples. So first one, using these arrays, what's the probability of DG with replacement? So we use the with replacement array. So we want the probability of getting a D, then a G. It's really important this order. They want D first and then G. So notice this is the only bracket they want. And there's only one of them out of a total of 9. So our answer is going to be 1/9. That's our probability. Let's try another one. What's the probability of a D and a G? Notice here they just want one of each. It doesn't matter the order. There's no comma to show you which one they want first. So a D and a G, and that's without replacement. So how many of these ones here are a D and a G? So you've got a D and a G here, and you've got a D and a G there. You've got 2. So your answer is going to be 2 out of the 6 outcomes. And that simplifies to 1/3. Let's try another one. So what's the probability of a vowel and a consonant with replacement? So we're going to use the with replacement array here. We want a vowel and a consonant. Here I've got a vowel and consonant. Here I do as well. Here I do, and here I do. All one vowel and one consonant. That's 4 outcomes out of the possible 9 outcomes. So it's going to be 4/9 as your final answer. And then lastly, what's the probability of at least 1 G without replacement? So without replacement, I want to use this one over here. So without replacement, I want at least 1 G. So I've got 1 G here, 1 G here, 1 G here, and 1 G here. So that's 4 different outcomes circled out of the 6. So 4 out of 6 simplifies to 2/3 probability for that question. Hope this helps you with the questions. Good luck.